Hello everyone, my name is Aleksandr Zhabin, and in this short video I am going to explain to you what is a quantum group and how it can be a global internal symmetry of a quantum field theory. This presentation and the poster that I will present at the Strings 2025 conference is based on these two papers, which you can see on the slide. What is a global symmetry in quantum field theory? The most standard answer is that symmetry transformations form a Lie group or a discrete group that acts locally on the fields of the theory. However, the recent developments generalized the concept of a global symmetry. The two well-known generalizations are higher form symmetries and non-invertible symmetries. What we learn from the studies of non-invertible symmetries is that symmetry operators do not necessarily form a group structure. Instead, they can be described by a set of topological defect lines. We focus on yet another algebraic structure, a quantum group, and argue that it also can serve as a global internal symmetry of a quantum field theory. So, what is a quantum group? We focus on the simplest quantum group denoted as UQ of SL2. It can be understood as a deformation of universal enveloping algebra of standard SL2 algebra with a deformation parameter Q. In the formula 1, you can see the commutation relations of this deformed algebra. After taking the parameter Q to 1, one recovers the commutation relations of standard SL2. Yet UQ of SL2 is in fact an algebra. For historical reasons, this object is usually called a quantum group. At the first glance, it is not that different from SL2 or SU2. The finite dimensional irreducible representations are also labeled by half-integer numbers, spins. However, what actually distinguishes the quantum group from standard Lie algebras is the action of its generators on the tensor product of representations, which is given by the following deformed coproduct for generators E and F. Q to the H is still a U1 element with the usual group-like coproduct. So, what does it mean that a quantum field theory has quantum group as a global symmetry? Formally, it means that, first, quantum group generators commute with the spacetime symmetry generators. Second, QFT operators transform linearly under the quantum group action. It implies several important features of QFT operators. First, the correlation functions satisfy certain relations, which we call the quantum group word identities. Second, the quantum group word identities are incompatible with the locality condition. Local operators have to be replaced with operators attached to topological lines. The permutation of such operators is then given by a special element from the quantum group called the R matrix, and the locality condition has to be replaced with the braid locality condition. Finally, the topological lines corresponding to the quantum group generators have some novel properties compared to the usual topological defect lines. If you are interested in the quantum group symmetries, please come to the poster sessions at Strings conference and I will be happy to explain the details for you. In particular, I will show how to construct the correct quantum group coproduct. I will explain what are the constraints on the form of the correlation functions both in QFT and in CFT. I will then discuss a particular example of a theory with quantum group symmetry arising from a spin chain. Finally, I will explain one of the methods to solve this theory with the help of Coulomb-Gas formalism and how to realize the quantum group in this formalism. Thank you for your attention and see you at the conference.